Yeah, kind of. Okay, so I was able to get the homework videos up for 7.2 and 7.3, and I just put up 7.4, so that's tonight's homework. So I'm kind of caught up, but I want to try and get ahead, so we'll see how it goes. What's that? Oh.
I thought you because this morning you only had 7.2 on there.
7.3 isn't there?
I didn't see it
It's
this
only
morning.
there, like, it only shows 3 videos, and whenever you watch one of the videos, it shows up on the recent one.
Oh, you know what? I must have not added it to the playlist. I can do that.
The ones you can see.
I can fix that. Yeah. So yeah, it should be 7.1 through 7.4 should all be there now, but I'll double check it. Okay, we are going to move on. 7.4 trig functions of any angle. So if you recall, what we were doing in 7.3 is we were restricting all of our attention on angles that were acute angles only. So that means that they were, less than 90 degrees, between 0 and 90. So now we're going to open it up to all angles. And before I begin, I want to make sure that we're clear in understanding what these are. Sine of 0 degrees, cosine of 0 degrees, tangent of 0 degrees. There were common angles, right? The ones that you're supposed to know. And the ones were like, 30 degrees, 45, 60. But let's make sure we understand what the trig functions are for for 0, each of the 3 here. So remember, the idea was that we draw a triangle, right? We have an angle in here, theta. And we can call this side A and this side B, this side C. And the definition was sine of theta was B over C. Cosine of theta was A over C, and tangent theta was B over A, right? Something like that, according to this triangle. But if our angle is 0, right, then you don't have a B, right? B is actually 0. And you could also make the argument that C and A are what? If this hypotenuse, if I close this angle down, right, don't C and A have to lie right on top of one another? So aren't they the same length? Does that kind of make sense? So this is a general triangle. Let me draw the triangle with an angle of 0. It's going to look ridiculous, but that's what it would be, right? And this length right here is A, but that's also C. And B over here is 0. Does that make sense to you? So in that case, what would sine of 0 need to be? Sine of 0 degrees should be B over C, but that's 0 over C, right? 0 divided by any number other than 0 should be 0, right? So sine of 0 is 0. Make sense? And then what about cosine of 0? It should be A over C, but A and C are the same numbers, aren't they? So just 1. So cosine of 0 is 1. Remember, A is equal to C, so you could scratch out the A and make that C. C over C is 1. And what about tangent of 0? 0 over A, right, which is 0. I think now a more interesting question would be, what are the reciprocal functions?
Undefined, 1, undefined.
Okay, so cosecant of 0 should be undefined because you're flipping these over, right? And you're getting C divided by 0, and division by 0 is not allowed, right? It's undefined in our number system. So this would be undefined. We don't say no solution. We say undefined. And then cosine, flip it over, you get secant of 0 should be the reciprocal of 1, which is just 1. And then cotangent of 0 should be also undefined, right? Because you're going to get a over 0, undefined. All right, does this make sense? All right, let's try the same things for 90 degrees. So what would happen if we change this to 90 degrees, 90 degrees, 90 degrees? Well, that's going to be weird, right? Because can you even draw a triangle that way? I mean, I can't really draw a triangle, can I, that does that? Where the heck did that go? I always lose that little green towel. I know there's one back there, but I had one up here. Do y'all see it somewhere? Here, throw that one to me. Thank you. Oh, she took it. That's right. She took it when she raised the board. All right, so this is really strange because I'm supposed to draw a right triangle, but my theta in here, right, this angle right here is supposed to be 90, right? But a right triangle, you have another 90, don't you? It's impossible, right? But here would be my best attempt at it. My angle here is 90, so I go straight up. And then I can't go over at all, can I? Because if I try and move this over, then it's not straight up anymore. So this would be like the same situation we just had, but laying flat, but straight up instead. Do y'all agree that this is going to form like a 90-degree angle here? Follow?
I remember at the beginning of the semester you said it was like a spherical triangle, like if you were to go like from...
On a sphere?
Yeah. Wouldn't you be able to do that?
Yeah, but no, we're not even living in that universe of the spherical. Yeah, we have to stay in our fishbowl here. We are not allowed to move out of it yet. So let's just see if we can make any sense out of this. What would be the adjacent side to this angle? What would be the length of the adjacent side in this case? I know it's not a triangle, but I'm trying to get you to think through it. Look, we just drew this picture, right? And we said that the height of the triangle was 0. Well, wouldn't this, if I draw this, wouldn't the left and right, the width of it be 0? Yes. So you could say that A is 0, right? And B and C are the same this time, right? B is equal to C. Again, here's my triangle, A, B, C, theta. If I rotate this up, this side comes over, and B and C become the same, and A becomes 0. Yes? You'll see that?
Yes.
Okay. So with that in mind, what would sine of 90 degrees be? What would sine of 90 be? Sine is the opposite over the hypotenuse, right? So it should be B over C, but B and C are the same, aren't they? So it'd be 1. What would cosine of 90 be? So it'd be A over C, so it'd be 0 over C, which is 0. And then tangent of 90 would be undefined, because you're going to try and do B over A, right? B over A? This one over this one? So B over 0, undefined. Does this make sense?
The sin value of 1 comes from
The fact that your opposite side and your hypotenuse side have to become the same side means that the ratio of the two, if these two are the same, then the ratio is 1. Yeah.
Okay. So anything above itself.
Yeah. What about the reciprocals of these? What's cosecant of 90? 1. Secant 90 would be undefined, because you're trying to flip this fraction over. You get C over 0 is undefined. And then what about cotangent of 90? 0. That's okay, you can do that, right? If you flip this fraction over, 0 over b is defined. Okay. While we're on the topic of division by 0, does anyone have a good explanation? I'm not saying I do, but does anybody have a good explanation as to why this first one is 0 and the second one is undefined? Or have you ever heard a good explanation?
You can't have a whole nothing. You can't have a fraction of nothing.
Can't have a fraction of nothing?
Well, you have 4 over 0.
Okay.
So it's usually meant to incorporate. You have 4 equal quantities of something of a whole. When you flip it around, if you have 4 over 0, you have 4 over 0 of nothing. There.
I think you're saying exactly what I want to say. I'm going to say it in a different way, though.
Sorry.
Yes. No, that's good. That means you understand it in a way that you need to, but I'm not going to verbalize it the same way you did. Anyone else have another explanation? I mean, you've been told you can't do this, right? And that it doesn't make sense in our number system to do this. Try and give you a reason why. And let's put 1/4 up here also, because that's something we can all kind of visualize. So when we say 1/4, right, what we're saying is, let's say you take, I don't know, pizza, right? We're going to cut it into 4 equal pieces, and we're going to take one of them, right? And if we did something like 3/4, then you would take your pizza and cut it into 4 equal pieces and take 3 of those 4, right? Now let's look at that in this situation. Here, we're going to take our pizza and cut it into how many pieces? 4, because the denominator is how many pieces we're going to cut it into, right? So 4 pieces, and we're going to take how many of them? 0, so I'm going to have nothing, right? And the pizza's there, but I'm not taking anything from it. All right, here, I'm going to take my pizza and I'm going to cut it into 0 pieces, but that's impossible because the pizza itself is 1 piece, right? If I do this, then that has to be a 2, right? If I do this, the bottom has to be a 4, but the only way I can actually do something with it is if this number down here is not 0, right? It has nothing to do with the 4. The 4 is irrelevant. It's the fact that you can't say you're going to start with something and then cut it into nothing, or cut it into 0 pieces. Make sense? That's the best I'm going to be able to do for you.
You can't make 4 fractions of a pizza that isn't there.
That's right. Yeah. A more interesting question, though, is what's this?
Also
Undefined?
still divided by 0.
Yeah. But this is actually what we run into this in calculus. This is the big question. This was the big hurdle for Isaac Newton and Leibniz. Those are the 2 fathers of calculus. This was the big hurdle. They were trying to get around this problem. And this problem comes up more times than you think it would. And I'll give you a very specific example. Don't worry, we'll get into today's material, but this is called precalculus, right? And this is a calculus idea, so we may as well introduce you to it. So do you all know what the definition of speed is? What is speed defined to be? Now, we're talking about physics here, okay?
Mass over acceleration.
What's that?
Mass over acceleration.
Um,
Velocity. Speed is velocity. Velocity and time.
Distance over time. Distance over time. The distance you travel over the time it takes you to travel that distance, right? That's what we call speed. And what we should actually put here is your average speed. Your average speed. Because in order for you to travel a distance, right, like you're driving along or something, you travel some distance and you measure how long it took you to do that, right? And you divide the two and it gives you the average speed over that interval. So for example, if you have time here and you have distance here, and let's say you start out in your driveway and you measure, you've gone 0 miles, and you start your watch and you start driving to school or work, you can measure how far you've gone and how much time, right? So you start driving, maybe you have to stop at a stoplight, and then you continue driving, another stoplight, right? And if you travel anytime between the hours of 7 a.m. and 8 a.m., it's like this, right? It's like this, stop and go traffic. Anyway, you get to your end destination, right? And what you do is you take your time, okay? Your time will be this distance, or this measurement, and your distance is this, right? So if you take, let's say you went 30 miles, and let's say it took you 2 hours. Then you will have traveled an average speed of what? 15 miles per hour. So you're taking your distance you travel and divide it by the time, right? Okay. Visually, what you're actually doing is connecting these 2 points with a straight line, and you're finding the slope of that line. Because isn't slope rise over run? So if you take the rise is 30, right? The run is 2. 30 over 2 is 15. So your average speed is the slope of what we call the secant line, but don't worry about that. Okay? That's this. So Newton and Leibniz had a more interesting question. Their question was, I'm not interested in your average speed. I would like to know at that particular instant in time, right there. At a particular instant in time. You're driving along, right at some instant, whenever, can we talk about speed?
Yes.
How?
Well, we have better measurements. We have more significant figures inside the measuring device to create more points of measurement.
Yeah, but I'm talking about an instant in time.
Well, if you have a straight line for 2 points,
Oh, okay, I
maybe
see what
we
you're
could try to
saying,
get
yes.
a tangent for
Physics
that point.
application, maybe.
Yes. What happens to your definition of speed, though, if you try and talk about speed at a specific moment?
Yeah, because a moment in time, like he's saying, it's only a fraction of a second that you're trying to collect the data.
Yeah, but it's even less than a fraction of a second.
Yeah, it is. It's,
right?
It's infinitely small. That's why they're very smart physicists.
How much? Well, how much distance do you travel in an instant?
It's the measurement. That's where the idea of the measurement now becomes hard to define.
Okay, so if I'm running along here, right, and then someone snaps a picture of me running, at that instant, how fast am I going? The problem is that in an instant in time, what's your distance? How far do you travel in an instant? 0, okay? How much time elapses in an instant? 0. And you have a problem here that you can't compute speed at an instant because you run into this hurdle of 0 over 0. And Isaac Newton was able to overcome that. And what it required is what you start Calculus 1 with, and it's this concept of what's called the limit. And what we do is we're actually able to get around this 0 over 0. And that's what all of calculus is pretty much based upon. And it's amazing because you can actually do it. So when you're driving down the road, you look down at your speedometer, it's giving you your instantaneous speed, right? That's what it's doing, right? But that's a hard thing to measure off a graph. I mean, it's difficult. And I've heard of like cases in court where people go in there and try and argue, you can't, try to fight tickets, They're like, I wasn't going 70 miles per hour because 70 miles per hour is an average speed and I wasn't even traveling for an hour. And they try and get out of the tickets, making some argument that instantaneous speed is impossible to measure, but it's not going to work. You'll lose that. It's already been fought and you won't win that battle. But it's a good argument. 0 over 0 is undefined. Okay, back to trig functions. All right, so we've got sine of 0. We've got 0 degrees, right? Sine, cosine, tangent, and then all the reciprocals. Got 90 degrees. What about 180 degrees? What would that look like? If I had a triangle, so I'm going to start here. I'm going to measure my angle out like this, all the way over here. I can't draw a triangle, can I? Right? I'll run into the same sort of problem. Let me try and draw the triangle like this. Okay, do you all see this angle right here? That angle is bigger than 90. So this side, I'm going to call that A, I'm going to call that B, and I'm going to call that C. So do you see that if I do this, I don't really have an opposite side anymore? right? We start to run into like major issues with our right triangle. And that's what today is about, is like once we get past 90, like what do we do, you know? So all we do is we just rewrite or redefine our trig functions. And it turns out to be pretty simple. And the definition's pretty simple. 2.4, or 7.4, here's what we're going to start with. So suppose you have a point at the origin, okay? And then you have another point, anywhere, doesn't matter where it is, some other point A, B. Then do you agree with me that as long as this point is not in the origin, that there is some distance from here to here? And that distance we will call R. Then is there a relationship we could establish between A, B, and R? What is a relationship that we could establish? Actually, you know what? Let's change this to X and Y. We've used A and B. Let's use X and Y. What's the relationship between X, Y, and R?
Distance formula?
Okay, so you could do it off the distance formula, or you could just drop a little right triangle down right now, and you could use Pythagorean, couldn't you?
Yeah.
You could say this is X, this is Y, and so you would get X squared plus Y squared is R squared. So we have this relationship, right? Will that work for any angle or any point? So let me try and give you another one. How about over here? If I call this X and Y, and I draw a line connecting that point to the origin R, then, so this is actually a negative number, isn't it? And this is going to be a positive number, but does that matter in this formula?
No.
Why doesn't it matter?
It's getting squared.
Because you're going to square the x, right? So this relationship still holds, doesn't it? So we still have x squared plus y squared equals r squared. So you could still imagine this triangle x and y, and even though this is a negative number, it would not matter in this formula. Would that hold for any quadrant I go into? Yeah, it should, right? If I pick a point down here and I measure here, R, both the x and the y will both be negative, won't they? But that doesn't matter because in the formula I square it. So are you okay with no matter how you pick a point in the plane, that this relationship will always hold? Yes? Yeah? Okay. Now, from that, let's define the 6 trig functions. Here's their definitions. Sine of the angle theta is equal to, and by theta I mean this angle here. In this picture it would be that angle right there. Okay? It's the angle that goes from the x-axis to the terminal side of the ray that we draw, or the line segment. So sine theta is always y over r, cosine theta is always x over r, tangent theta is y over x, and then all the reciprocals are exactly as you would think. Just flip these over. Okay. What you realize is that if we stick ourselves just in the first quadrant, these definitions are exactly what we had before, right? Sine y over r, that's opposite over hypotenuse. Cosine is x over r, that's adjacent over hypotenuse. Tangent, y over x, that's opposite over adjacent. So everything still works with what we've done before, right? No, nothing has kind of gone haywire because of this. So with that, that's it. I mean, that's the definitions of sine of the 6 trig functions for any angle. So let's go ahead and try and find the value of one of these 6, or value of some angle that's not within the first quadrant. Let's go for something. Let's see how the formula will work. And we're going to do this first one by me giving you a point. All right? So example. the terminal side of an angle passes through the point -4, -7. Find the 6 trig function values. So what I would do is I would just start off with a picture, just to make sure you understand where things are. You have an angle, right? It starts out here, and its terminal side, which means this side here, passes through the point -4, -7, which is, if we plot this, 1, 2, 3, 4, 2, 3, 4, 5, 6, 7. It's down here somewhere, right? And so it looks something like this. This angle right there. I'm going to call it theta. That angle is definitely bigger than 90, right? This is not an acute angle anymore. But the definition of the 6 trig functions is very clear. We call this x coordinate x and the y coordinate y, and then we just plug in. So what's the only thing we don't know that we're going to need to know? We need to know what r is, right? But we have the relationship x squared plus y squared is r squared, right? You said that held for no matter where I was. So I need to go find r right now. So using x squared plus y squared is r squared, I know that what? -4 squared plus -7 squared equals r squared means 16 plus 49 equals r squared. So what's that, 50, 65? 65 is r squared. And then we take the square root on both sides. So root 65? Root 64. I can't stop doing it. Root 65. What, root 64, isn't that like
66.
what, are you thinking? Sonic?
No, Root 66 is the old.
Doesn't Sonic have a root 64?
They have the Root 44 cherry
Root
arm
40.
slush.
Is that what it is? Route 44?
Root 44, that's
64, 66 is a highway. Wasn't there an album named
Route
something?
66, which was famous, that connected Chicago to Chicago.
That's okay, that's what I'm thinking. Either way, it's Route 65, all right? And I'm not even going to worry about not rationalizing, but simplifying that, right? I'm just going to leave it. I don't even care if there's a perfect square in there. All right, and that's it. Now it's just plug and chug. You got R, crank it out. So what would sine of this angle be?
Sine is y over r.
So -7 over
60,
root
square root of 65.
65.
You can't have that square root at the bottom.
Hey. Okay, so sine is y over r, cosine is x over r, tangent is what? Good, it's 7 over 4 because they're both negative, right? Okay. Now, on the homework solution videos, I do the same thing that I'm going to do here, which is to get the other 3, you just flip these over, all right? Just flip them and y'all are okay with that? Mm-hmm. Okay. So would you agree that if somebody gives you a point, tells you that's a terminal side of an angle, that, I mean, the arithmetic is pretty straightforward? Yes. Okay. So what gets more interesting is when you're not given a point and you're given the angle, and then asked to find the other 5 trig functions. So let's start now with another example and see how we do with this. What is if sine of some, well, you know what? Let's do it this way. Find sine of 135 degrees. No calculator allowed. Okay, so no calculator. Now, if we had x, y, and r, we would be able to do it, right? But we don't have that. So what we're going to need to do here is try and get an understanding of where we are, okay, where this angle is, and then maybe use some knowledge of the trig functions that we already have. So let's see how this goes. I'm going to draw this. 135 is what? 45, 90, 135 is this. This is a common angle. This is an angle we should know. Okay, so 135 goes like this. Let's measure it here, 135 degrees. Now, when it comes to the stuff we did know, right? There were 2 classes ago, I think, I said there were common angles. We all need to know what the trig function, the trig values are. And what were those common angles that we had? Like everyone here should know sine of 30 degrees, sine of 45 degrees, sine of 60, right? Those are the ones that you're supposed to know. But then you're also supposed to know cosine and tangent, and right? So anything over here look like do any of those look like they might be useful to us? The 45, right? Because look at it this way. Let's say we don't know this point, right? We actually do not know what the point is. We could pick any point. As long as it's on that ray, we're good. This would have some x coordinate, some y coordinate, right? If we were to draw a right triangle right here, this angle would be 45 degrees, wouldn't it?
Yes.
And that might be able to help us get the value of sine of 135.
No, it's isosceles. It's
This one, because it's 45, yes. But tell me what you know about sine of 45 degrees. I mean, you should, again, know what that is. So sine of 45 degrees is root 2 over 2. Okay, we proved that in class or talked about that. Yeah, we did prove it. We proved that that was root 2 over 2. So is that going to be the same? Are we going to get the same answer here then? Because what sine should be the opposite over hypotenuse, right? Or in this case, because our angle is not acute, sine of some angle should be the what coordinate over what? Which coordinate? Y over r, right? The y over r? So would you agree with this? If I were to draw this, I know it's going to start to look complicated, but this y coordinate and this y coordinate are the same, aren't they? And the radius here and the radius here are the same. You agree? Because it's just a reflection over, and this y value is identical to that y value. So I should get this ratio of this side over this side, because that's 45. That ratio should be equivalent to the ratio of this over this. So would you agree with me that this is equal to sine of 45 degrees, which is root 2 over 2? Does that make sense? Because the y coordinates are the same, that should work. Question?
No, I see what you did.
You sure?
Sin 45 over 2 over 2. That's the same equivalent.
I'm going to leave that on the board. And now I'm going to ask you a different question. I'm going to ask you what cosine of 135 degrees is. Let's leave that over there. Cosine of 135 degrees. All right, so when I draw my picture again, this, we have this same angle, right? Like this. That's 135 degrees. If I pick some point here, x and y, right? Then the distance from here to here would be r. So that nothing has changed there, right? Can we use the 45 degrees again? So can you can you use this idea that this right here, 45, that's 45, and then drawing a similar triangle over here, saying that's 45, that we should be able to use that to get that answer? Or do you see a little bit of an issue? What was cosine of 45 degrees?
X over R.
The one that we had to remember. Root 2 over 2, right? So my question is cosine of 135 also root 2 over 2? No, okay? But it's just there's one slight technicality, and this is the part that's important. By definition, cosine of an angle is x over r. Agreed? So when we're looking at cosine of 135, I said, let's draw this triangle. If we drew this triangle, then our answer is root 2 over 2. And that would mean that this side over the hypotenuse is that number, right? But because we're in this quadrant, can you tell me about the sign of that x-coordinate? Is it positive or negative? This is a negative number, right? That's a negative number. And the hypotenuse is a positive number. And so when you set up this ratio of x over r, you're going to have a negative number over a positive number. So it's going to be the same answer as this, but negative. Does that make sense? Because in the second quadrant, your x-coordinate is negative, right? Because of that, the ratio here has to be negative. So this can't be the answer. It has to be that, but negative. So the answer here is negative root 2 over 2. I'm going to give you more to practice this, all right? See, I don't know if you can say there's even a lot of work that you're doing. It's just drawing and understanding where things are. Let's try another one. Another example, let's do sine of 7 pi over 6. All right, sine of 7 pi over 6.
210 degrees.
So you need to know where we are first, right? Okay, so let's figure out where we are. So we count by pi over 6s. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, and I'll put it in red. Wait, that's supposed to be a little smaller than that. Let's see, 30 degrees. It's just 30 degrees past 180, right? So there's my angle. And I'm going to stay in radians, 7 pi over 6. Now, like I said over here, when we drew that angle, I kind of used that to create this little reference triangle, right? And then from that, I was able to extrapolate this information, and then I was able to think about the ratio to change it to negative, right? let's see, where would we want to draw a triangle here?
30 degrees.
Where would it, okay, so 30, do you see it? Do you see this triangle? Pick a point here. This is the point x, y. We know the distance from here to here is r. How about this triangle? It's upside down, but is that okay with you? And then this angle right here is what? 30 degrees. Now, do you know anything about sine of 30 degrees? And I should use pi over 6 instead, right? It's pi over 6?
Yeah.
Okay. So do you know anything about sine of pi over 6? Sine of pi over 6, according to what we were learning before, is half. Okay? Now, is that going to work? Is that going to work? Yep, so sine of an angle, we said, is the y-coordinate divided by the radius. And when we're down here in the third quadrant, your y-coordinate is negative, isn't it? And your radius is always positive, okay? So that's good news. The radius will always be positive. So you know that the answer is very similar to that because the ratios should be the same. In terms of the length of this divided by the length of that, numerically they're the same. But it's just a matter of the sign, positive or negative. Your question? No? So this divided by this should still be that answer, but negative. So we get negative 1/2. Are y'all following this?
Mm-hmm.
Okay.
What if you took a 60?
What is what?
For the triangle to make, what if you took a 60?
What if you used 60 instead? For this same, well, where's, I guess I would need to know where your 60 is. Like, where do you see a 60 here?
On the other side.
Like from here to here? Ooh, that might change things, because if you drew that 60 like this, I think this is what you're maybe saying. Like this is 60 degrees here. This r is still that, but now, let me see, x. This would be your x still, this would be your y. But let me see. You're looking for y over r, right? Y over r.
Why still stay?
So now you'd have to be looking at cosine of 60, because you need y over r, don't you? And in this picture, the only way to get y over r
So,
is to do
those
cosine of
possibilities,
60.
right? So like, how would we know like which to use, 30 or 60?
Okay, let me do one more, and then I think we're going to kind of wrap it up, because we'll be able to say, okay, when we see an angle, here's what we'll do, all right? But I wanted you, the main point of this example and the previous one is that we have to pay attention to the sign of either the y or the x, and that's going to be determined by which quadrant you're in. Okay, let's get something out of the fourth quadrant. How about let's stick with sine and cosine because they're so much fun. Let's do sine of No, I'm trying to think of one that'll be
11 pi over 6.
That's a good one. 11 pi over 6. I was going to do something like 7 pi over 4, but I'll do 11 pi over 6. Sine of 11 pi over 6. So we need to know where that is, right? So you can count by pi over 6s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're here, right? So we can pick some point on there, x, y, and then this is r, right, the distance from here to here. Does it seem, again, natural to you to draw this right triangle? Does that seem natural? And if I do that, what is the angle right here? 30 degrees again, so I'm going to use pi over 6. So this answer should be very similar to sine of pi over 6, which we just did that, didn't we? And we got 1/2. Now, is it going to be 1/2 or is it going to be negative 1/2? Negative, because your y-coordinate in the fourth quadrant is negative. So it's going to be the same exact answer as this one, right? Negative 1/2. So this is going to be negative 1/2. All right. Now, getting to the question about how you draw your triangles. We have a definition here of what's called a reference angle. Okay, so if you draw an angle anywhere, we can always come up with something called a reference angle. And I'll show you in pictures what it is. If you want the definition, it's in the book, but I'm not going to write the whole definition down here because it's easy to understand once you see it visually. So I'll give you 4 different scenarios. Let's say that you have an angle that's in the first quadrant, an angle that's in the second quadrant, an angle that's in the third quadrant, and an angle that's in the fourth quadrant. And you pretty much, those are the only possibilities, unless it lies on the x-axis or y-axis, your angles are going to be somewhere else in one of those quadrants, right? Okay, the reference angle is the smallest angle between your terminal side and the x-axis. So when you look at this terminal side, you can look at 2 angles here, this one or this one. And you're looking at the smallest one between the angle, between the terminal side and the x-axis. So this right here would be, I'm going to call it beta, right? In that case, beta and theta are the same. Here, this is theta, but your reference angle, beta, is actually this angle. Right? Isn't that the smallest angle between your terminal side and the x-axis? Okay. Here, your angle theta is this one, but your reference angle is this angle beta, which is, again, is the shortest angle, the smallest angle between that terminal side and the x-axis. And then this one over here, your theta would be here, and your beta would be there. So here, beta is what we call the reference angle. And I didn't draw the triangles, but you can see that if we just drop from our point down to the x-axis, or up to the x-axis, we're creating that right triangle, and that's what we're working all of our geometry off of. So here's what we know. We know that if you're going to look to see what sine of an angle is, would you agree that it should be equal to sine of beta? Maybe, right? But it could be plus or minus that, right? It could be one of those two. That's the result here. How you determine the plus or minus is simply by figuring out what quadrant you're in. So cosine of theta will be plus or minus cosine of beta. And so on and so forth. Kind of make sense? Okay. Now, we're going to do a couple more examples, but I'm going to give you something that'll help you remember what's happening in each of the 4 quadrants. We have this very commonly shared picture. You may have seen this before if you've taken pre-cal. Y'all ever seen that before? All right. A way to remember that is, you start in the first quadrant and we go backwards with angles like this, right? Counterclockwise. All students take calculus. That's the way that I was taught it. There's other ways, but all students take calculus. And what this means is this. If we're just looking at the sine function, the cosine function, and the tangent, just those 3, okay? just those three, then in the first quadrant, all of them are positive. Okay, so the A here means all are positive. All three. Now, does it make sense that that would be the case? Imagine that I have a point here, right? I have something here, I have a point, I have an x and I have a y. The radius is always positive, right? If I take sine, it's y over radius. Over here, the y coordinate is positive. So you have a positive y coordinate and a positive radius. The ratio should be positive. If I do cosine, it's x over the radius. X is positive, r is positive, ratio should be positive. And then tangent is just the ratio of these two, right? Y over x. If these are both positive, the ratio should be positive. So all three of these trig functions are positive here, okay? Then if I move into the second quadrant, anywhere over here, x and y, this s is to tell you that only the sine function is positive there. Sine is positive. Which means the other two are what? Negative. Does it make sense to you that that would be the case? Yeah? Because sine is what? It's y over r. And in the second quadrant, your y coordinate's positive. So y over r should be positive. But if you look at cosine, it's x over r. And if you're over here, your x coordinate is negative. So you're going to get negative number over r. That's going to be negative. And then tangent, these two, ratio, one of them's positive, one of them's negative. Making sense? So here, both your x and y coordinates are negative. Right? To get down here, you have to go negative, negative. That means sine and cosine should be negative. But tangent will be positive because it's two negatives divided. And then the last one, in the fourth quadrant, only cosine is positive. All students take calculus. Maybe it's all students try calculus. Take, try, I guess it works. Yeah. All right, that should help us because remember, we're using that reference angle to draw a triangle, and really that gives us an answer almost right away. And then it's just a matter of determining whether or not it's plus or minus, and this can help us real quickly determine which one it was. All right. Let's do another one. I'm going to say I would like to know what cosine of 37 pi over 4 is. Now, that means that you're going to have to count around 37 times, right? You could do that? I'm going to do it that way first, and then I'm going to do it a different way afterward, all right? But 37 pi over 4. So here's pi over 4 here. These are them, right? I can count around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? 17, 18, 19. Where am I? Where am I here now? 24. So every time I go around, it's 8 of them, right? 8. So 24 and then 36. And I'm supposed to go 37 of them. So what did I say? 24. Why did I say 36? It's a multiple of 8. 32. I'm here at 32. And then 33, 34, 35, 36, 37. I'm right there. Make sense? I mean, you're just physically going to count around 37 times. What's this reference angle? 45 degrees. So what I know is that this should be the same as cosine of 45 degrees, which is pi over 4. But plus or minus, I'm not sure yet. Right? It's one of these. Cosine of pi over 4 is root 2 over 2. So it's either plus or minus root 2 over 2. Now, which one is it? Yeah, because I'm in the all students take calculus. The only trig function that's positive here is tangent. And I'm asking for cosine, so it's got to be negative. Was that a comment or a question? Or a complaint? I don't know, I heard something.
It's gotta be negative. I'll do both.
We good? All right, let me show you a different way of doing the same thing, but not counting out. All right? What you could do is this. We all have to remember that one full rotation, right? One full rotation is 2 pi. Okay. So what I can do is I can say, what is this number, 37 over 4? What is it approximately? Let's see. 4 goes into 30s. About how many times? About 9 and change? 9 and change, right? 9 and change. So why don't I do this? Why don't I take 37 pi over 4, and why don't I just subtract from that? Each one of the full rotations was what? 8. Each one of these is 2, right? So I know that this number is about 9. So why don't I subtract 8 pi's? I'm doing 8 because 8 is a multiple of 2. And you have to get a common denominator here. 37 pi over 4 minus 32 pi over 4. Agree? And then what does that leave you with? 5 pi over 4. And this right here should be an angle that you're familiar with. What I'm doing is, instead of going around like 2 pi, 4 pi, 6 pi, 8 pi, right? Instead of doing that, I'm taking out the full rotations. I'm taking out 4 full rotations. And then it gives me an equivalent angle. So 5 pi over 4 is 1, 2, 3, 4, 5. So we're at the same place. So you're free to do this either way. It doesn't matter. I personally, if the number's small enough, I'll just count it out. I don't care. I don't want to do the arithmetic. All right. What is tangent of negative 210 degrees? So 210 degrees, starting here, we're rotating around. We're going clockwise, right, because it's a negative angle. So this is 180 right there. And then I've got to go an additional 30 degrees, right? So it should put me somewhere around there. That's negative 210 degrees. My reference angle is what? 30 degrees. So my reference angle is this one here. Now, what I know is that up there should be very similar to this, tangent of 30. Do we know what tangent of 30 is? Probably not offhand. What's up? I think you're in the wrong place. That or you haven't been here for 3 weeks. No, I think you're in the wrong place.
Yeah, I definitely am.
Okay, all right. I did that one time. When I was in college, I was going to a party on a weekend, and they sent me to go pick up beer. So I went to go get beer, and it was an apartment complex I'd never been to before. So I went and got beer, and I came back. I had like the cases, and I went and I opened the front door, and there was some dude sitting on his lazy boy naked watching TV. It was like a Friday night, and I'm like, oh shit. Wrong apartment. But the guy had his front door open. It was weird.
He was waiting on you, man.
I did leave.